Hi everyone. I've been on a bit of a roll, so I've actually cranking through three or four of these today, just because I like going through as much as I possibly can. I don't know. I get excited teaching about object-oriented development. So we're gonna finish off at least our initial intro to objects. There's still lots more to go. People spend their entire lives looking at this sort of stuff and spend their entire lives programming in these kinds of languages. So, just in case you think there's a lot of content, yeah, that's because there's a lot of stuff to go over. Uh, so, we're going to look at some other little quirks of of the language itself, things that weren't available before, and then hopefully we'll have a chance to revisit our linked lists again after that. But I like to call this, that, and the other thing. Um, so I thought I had that as the name of this thing, but yes. Anyways, this, that, and the other thing as the name of the lecture, because we are going to look at what static also means, what this means, it actually means something, and we're going to look at the other stuff that's in C++. So let's get going with the full screen finally. So we were looking at access control very, very briefly, and we were talking about getter and setter methods, that you do not leave your functions that you don't want everyone to be able to access. If it's a function that you're not doing error checking for, a function that only your class is going to use, that better be a private or protected function. If you have variables that no one else should be able to touch, those should be private or protected as well. If you make it public, you can expect people to try and abuse it. So constant variables, or they're not variables then, constants, for example, that's fine. You can make them public because you can't change them. People can access those values, but they can't change them. So much like global variables, we don't like to use global variables in C. We don't like using public variables in C++ for a class because people can abuse it. We Well, hopefully it won't be a horrible quiz, but it might be a horrible quiz for this past time around when we're looking at how we parse up and change CPP files. How we go from all the class being defined in one file, one go, to being spread out over .h and .cpp files. And so I asked you to modify the student class to actually be across a .h and a .cpp file. And well, we looked at examples of this, but then I asked you to implement get name and set name. And then we had a quiz on that. We're going to look at protected, private, and public very, very soon. Lots more illustrations just because I like beating a dead horse. But we'll get to others. I wanted to get to a couple other things first. So, um, so one of the things I wanted to point out is if you have two classes that are very similar, for more, I guess, heuristics or ways of thinking about code, if you find yourself re-implementing things over and over again. So I have a class of the pink ghost, and I have a class for the orange ghost, and I have a class for the green ghost, or whatever the case is. Why don't you merge them? One of your jobs is to, when you're refactoring or when you're looking at your code, is to find the right size object type. So instead of having a pink ghost class and a green ghost class and a blue ghost class, what you would end up having is a ghost class where you can have the color being a variable and the logic of the ghost being a different kind of variable or different kind of set of instructions. Or when we deal with inheritance, we have another technique where we say we have a ghost class and then we have subclasses, which we'll get to that soon. But what we're trying to do is avoid duplicating code. So if I have Ms. Pacman and Pacman, the only difference is a bow. Who cares? It's going to be the same class, and you'll have a Boolean. Is the bow showing or not? Flag in it. You don't want to re-implement everything again, right? You're trying to find the right design, and that takes a lot of time and a lot of experience. Um, and if they're two classes are related, you try and merge them as much as you can. So here might be a very, very bad Pacman example. In fact, it is so bad that boo, yeah, I did not let I put in there and intentionally left it in there just because this is an example from other classes and you might see this online. You might see people throw this kind of crap at you, but this is why it's boo. Look at that thing. Boo. Public variables. No, 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 no. Now, for this example, sure, we can do something like that where we have a player P, we have 5 enemies that we're going to be creating, and we will have all 5 enemies, by the way. Whether we have 4 enemies or not, we will make 5 enemies because I'm not calling new on any of these things. Uh, we have functions associated with this, so we can have an update, a draw, and a wait function. In fact, this, in case you're wondering, is the lifeblood of most video games. Here is our we have an infinite loop unless the life goes away, or potentially if you cycle through and loop over the number of levels. Actually, no, not even in Pac-Man. You eventually will die. That's the only way to stop the game. So we have an update which updates. You take user input. We have a draw which draws everything on the screen, and then you wait a certain amount of time. You might also have a UI section as if it's separate from your update. So takes user input, ghosts move as a separate thing, so all the logic for how the ghosts are going to move based off of the current situation, and then a draw phase. And you have an infinite loop for that, and that's a video game loop. That's actually how games are made, where you have user input, updating stuff, drawing stuff, rinse and repeat. We will look at this again later on when we look at model view controllers. This is a standard practice for everything across the board, from video games to every single graphic user interface on the planet, from your phone to to a Windows machine, like the Windows interface, to a Mac interface. All of them do the same approach because it works. It's the only way to not be driven mad, is to separate drawing, logic, so how things interact or do things, like animate, and user controls. And you keep those concerns separate. Again, this is object-oriented program. We have these objects that do different things based on the verb. So we have objects that purely paint stuff, that draw stuff on the screen. We have objects that handle mouse and keyboard events from the user, or touch events from the user. We have other we have objects that are based around, that have a UI to them, like the ghosts themselves, which just move based on a timer. They don't know about the user input. They don't know that how the user is interacting with the system. They don't know even how drawing works. They just control where the ghost is located and how it moves around on the screen. Again, it's how you parse or break down big problems, and that takes time and exposure to different approaches. In case you didn't know, there is a word static, and it comes up in weird, wonderful places in C++. Static is one of the most misunderstood things. Even I still have trouble understanding static. It just, every once in a while I have to sit back and take a second to think about it. Static is nothing to do with electricity. It has nothing to do with not changing. My thing, if you say something is static, I think it does not change, right? It is a static. The ball is static, meaning it is not moving, right? That is what the term means, non-moving. Opposite, what you would think the opposite of dynamic, but static doesn't actually mean that. Static, it does somewhat relate to it, but static is not directly that. Static might be, it is an aspect of the class, not the object. And therefore, it doesn't matter how many objects you have, it is part of the class. And more importantly, the reason it's called static is it's because it's created at the very, 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 very beginning. Not when you make an object. It's always there. So if I have a static variable, I get that variable at the very beginning my program starts. Before I create objects or do anything like that, that variable is there. It's there at the very end of my program as well. And it relates, here's the kicker, it relates to the class, not the individual instance. And that makes no sense to most of you, I'm sure, right now, the way I said it. So let me try it another way, because I can say it a bunch of times. I need to find the right thing that makes sense to people. Normally it takes 4 or 5 different examples. A static instance variable might be automobiles number of wheels, or number of wheels for a particular kind of vehicle. So we have a vehicle class, or let's say a car class. The number of wheels for any given car is 4. Irrespective of what instance you have, all cars have 4 wheels, if we're going to say, at least all cars have four wheels. It might be the number of instances of a particular object that we created. That's not so the class knows how many objects were created. Each time you make a new object, that number increases. That would be an instance, that would be a static variable. So every time I make a new object, this counter that is related to the class, not the object, to the class increases by 1. That's the classic example where you're trying to count the number of times I made an instance of this. It is because it's not affecting the instance of that particular thing. It's affecting all of that particular class. Hard to explain. So let me think if I can come up with another example. You can have oftentimes for like a student ID, for example, you might have the next available student ID. Every time a new Carleton student comes in, you give them that student ID, you generate a new student ID for all Carleton students. That student ID number is kept as part of as a static variable in the class student Carleton student. Each Carleton student will every time you make a new Carleton student, it gets that ID, and then you generate another number over and over and over again. You can just use that static, but you would say Carleton student dot next ID or something along those lines. We can even have get. We can even have static functions. So instead of saying Carleton's, my student dot get instance count, it's Carleton student dot get instance count. It's related to the individual, so it might be. I could have called it student, I guess. The idea here is it's not related to the individual Carleton student you created. All Carleton students share this function. All Carleton students, the same function. They all point to the exact same function. They don't have their own instance, their own copy of that function. Every single one of them point to the same instance of that function. Or I might have a variable that is static and that all Carleton students share that data, that everyone has that same common reference point. Think of it, what Seinfeld was for water cooler conversations at businesses afterwards, right? Or I guess Tiger King now, right? It's a shared thing that everyone has in common. So, static functions can't use, by the way, static functions cannot use object variables. So I cannot get something involving that particular Carleton student. I can't get that Carleton student's ID. All I get is static things that are related to the static class itself. I say this, one of the reasons I like pointing this out is, as I know as an undergraduate, I got stuck on this, didn't know what the hell static meant, and I just changed everything to static. And essentially, when you do that, you regress the entire language, just regresses back to C. Is if everything's static, you don't have objects doing their own thing. You just all data is shared amongst every object. Um, and static functions look similar to C because you pass in a lot of data. You can't assign that the object actually has their own data. You have to pass it into the function itself. So a variable is called static because it retains its state between calls to that function. It's not specific to the object. So no matter what happens, that function stays the same no matter what the object that's calling it. That's why it's static. It does not change in that respect. When I modify data in a class description, the static keyword means that one of the copies of the member function is shared amongst all instances. So I make a variable or I make a function and it's shared amongst everybody. Every single object shares that one instance. The function is accessed by all static members. Static variables, it's called static because the variable is reserved immediately, not later. So as in, it's not going to change when I get that variable. When I call a function, I make a new variable. This thing is when I start my program, I get that variable. That variable stays around the entire length of the program and then gets given back later. That's why it's called static. It doesn't change. It's not added and released and all this kind of stuff later. You start your program, you get every single static variable. One of these things is you just got to practice with a couple of these to get your head around it. Because until you make it your own, it's not immediately obvious. But static doesn't mean it does not change. Static means it's shared amongst all objects. So I can have a number of wheels for a car. That's number 4. And so if I have a particular car, I could say car dot number of wheels, and that'll give me the value 4. But they're all being shared. But it's also, in this case, it's a constant. So I could say, I should make this capital. Car. Okay. So I could say, car dot. I gotta stop moving my screen here when I write. That's equal to the value 4. If car dot right, that is a static variable, and that's always false, right? I may also have a variable that is cars on the road. Every time I make a brand new car, this number increases. So I have no cars on the road, it starts at 0. It always starts at 0, by the way. Uh, Static variables always have some default set value that they have. All right, so I start at the value 0. I'm going to clean that up. I always start at the value 0, and every time I make a new instance of a car, boom, that increases by 1. I may have a function where it adds another car to the road, that sort of thing. But these things here, like miles per gallon, fuel in liters, the current speed of the car, that's the individual car I create. I make an instance of a car, it has a certain miles per gallon. A Mazda 6 and a Ford F-150 do not have the same number of miles per gallon. The number of liters of fuel that they have, not the same between any two cars, right? Or statistically, it's highly unlikely. The current speed of the car is going to be different, right? They're all driving at different speeds. They're all different cars. Each car is an instance, but the number of cars on the road, that's shared amongst all cars. Okay, I may have a bit student. So here is this name of the school that everyone can share, for example. Uh, it has an ID as a character name. I could get the school name as a static function, and it will return the name of the school, right? It depends on how I want to go about implementing this thing. Oh, and by the way, if you want to change the value in the CPP file, you got to do this sort of thing. You would need to, I have a school name here. It doesn't get set to anything by default. So at one of my lines of my code, I have to put this line outside of a function. I have to put like static char bit student : I'm going to initialize school name to being Carlton. That's on a separate line outside of a function. So here would be more examples of a class. Here I have 200. I'm going to make 200 students. This is for a particular school. When I want to add a student, maybe I'll have some kind of static variable that will change. That's the number of students I have in my school. And maybe I want to print all the student data for the entire school, in which case I'd go through that entire array, printing out all the student information for each one of those students. So let's do print student data. One of my functions here, right? Okay, if I'm going to print my student data, well, first of all, I can keep this number around. I might want to keep this number around. Like it's. Let me think about. Let me find a way of framing this. When I make a school, I will make an array of exactly 200 students. Whether I need 200 students or not, if I have a school of 20 or a class of 20 students, or a school of 20 students, I guess, doesn't matter. I still use all 200 slots and I make 200 student objects. That's what this thing will do. I will make 200 student objects in a row, just make 200 of them. And then I have another variable around saying how many of these things I actually made, right? If I only have 20 students, I make 200 student objects and I only set up the first 20. That's what this thing is going to do. I start at 0, go to 20, and for every one of those students, I print the data. This is when, remember I said earlier, most of the time you end up doing a dynamic object, because why are you making 200 student objects if you're only using 20 of them? But so I'm going to go through all 20, let's say, student objects, and I'm going to print the student data. That would be printing the student all the printing all the student data, and that would be a function. So I could take the school, say print all the student data. That in turn calls the print student data function for each of the students. So essentially you go to the school, say print all your student data. The school then goes to each of the students and goes, hey, print out your own data. When I want to add a student, oh, let's go back one. So this school, this is a member variable because each school is going to have a different number of students, right? If one school is bigger than another one, it has a different number of students. When I add a student, I will set the ID for so I go to the individual students thing, I set an ID to whatever the size is if I want to keep that around. Um, and I might do something like this. Right now, every student, the first student is numbered 0, the second student has the ID 1. These are not very good student numbers, right? So maybe I have some kind of function, a static function, that allows me to get the next available ID. And every time I get the next available ID, when I pass it out, I make a brand new ID. So every time I query for a new ID, it changes the ID on me. Just get the next available one. And I could then use that, put that in here instead of size, and then increase the size. This would be a function that is, so let's actually, I'm going to put that in there. So let's put this in there. And I would have to check on this one. I'd implement it myself and then figure out if it's in the CPP file or not. And then I'd have to have some kind of static variable. So maybe I might pass in some value. So I might do this. It's hopefully fairly simple. Return size is a variable, so I'm going to put in a size here. I can't just use the member variable. It's a static function. So I can say return let's say 10,000 mod, and then let's figure out what number I could put in there. 2193. I don't know, some number, right? I just want some ID that is not 0, 1, 2, 3, 4. I want some value that is going to be relatively safe. Um, or maybe, well, maybe I don't want to use that number. Let's try something else. Plus 2193. That's a random number I'm just coming up with off the top of my head. And mod 2000. And then I'm going to also plus 1, 2, 3, 4. I would just want some random number. Or hopefully random number. That's what I'm trying to do with this thing here. Just generate a student ID. Ideally, my student ID, when I make a new student ID, each time I make a new one, it is guaranteed not to have a collision or not to be a duplicate of some other student's number. So maybe it's 2193 plus whatever my size was. That would also work. Well, we could probably make it easier. Sure, let's do it that way. So guaranteed to not have a collision. The size is not going to decrease. It's going to start at 2193, then it's going to 2194, 2195, 2196, all the way up. And so at some point in time, your student ID number that you're given is like 5023. That's not actually the student number that you had. But as each student comes into Carleton, the size of that number gets bigger and bigger and bigger. It doesn't replicate, it doesn't repeat because it's static. All right. So, uh, then in the previous example, as I said, we're going to be making 200 uh, 200 students for no other reason other than we didn't want to make a dynamic array. That's going to be a lot of memory. In fact, I'm going to use 200. Maybe I only need 10. Maybe I need 10,000 though. And it's hard to change later. It's hard to figure out how big it needs to be. Sometimes you're going to have a huge number that you need. Sometimes you'll need a small number. And either you waste a lot of memory or you spend a lot of time trying to figure out what the heck's wrong with your code. Hard to edit, hard to rearrange the list, hard to change things around. And similar to what we did with malloc, we need new and delete. And we've sort of skirted around the issue of what new and delete are, but let's deep dive into it. That's new stuff for C, or sorry, for C++. Instead of malloc and free, we have new and delete. So here is me making a static array of 200 elements, or this is me making a dynamic array of 200 pointers to students. So I have a pointer, two pointers. It looks like here's my array. I now point to this student. This points to like a student over here. This points to a student over here. I'm making all these students. I have an array. This right here is an array of pointers to, so it's an array of pointers. That's why it's a star star. I get an array pointing to a bunch of pointers. This is a static array of pointers. In either case, both will work in our case, and in both of these cases, I'm not going to make 200 students here. I'm making, in this particular case right here, this first case here, I'm making an array of 200 pointers. I'm not making the students at all. I'm just making pointers. I could set them all to null to begin with if I want to. And every time, and so now I don't even have to figure out how big the size is. I could just walk down, see how many things are null and how many things are not null. Okay, if I add a student, it would be I'm going to take my particular student at the particular size. I call new student. I will make a brand new student, and I'll point to that brand new student that I created. I take the brand new student that I've created, and I could set the ID. Both would also work perfectly well. The idea is we have to be very comfortable with our pointers because pointers are going to be everywhere. I can make a dynamic array, which is a pointer to the array, and the array itself is full of pointers. So I need to know how I'm pointing to a pointer, for example. Um, and every time I call new, I get a pointer. I don't get an actual object. I get the pointer to the object. It's what C does. So I get a pointer to the object, not the actual object itself. When I'm done with it, I need to call delete on the object, not, I can't just get rid of the object itself. So, um, H. So I could have something like this. I is equal to 0, I is less than size, I plus plus. All right. I'm going to not use the curly braces simply for space. That's the only reason. Oh, I need to delete this. I think we'll actually see this in very, very soon. Delete. That will delete the individual instance, and then this will be deleting the actual array. The array is down here. Deleting the individual objects is the line above. They are different. I will go clunk, 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 and then afterwards I will get rid of this whole thing. That's the step two. That's this thing right here, is getting rid of the clunky parts here. This is killing off each of these things. So when I'm done, I also have to clean up. Much like when if I make a dynamic students array like here, I would have to call delete. In this case, I don't have to call delete. I didn't call new. Every time I call new, I got to call delete. You have to play with this until it becomes, you make it your own. Um, if new was called, I need to call delete. So this is a lot to take in, but let's just take a step back again. I can make a dynamic or static array every time I want, but if I have an array of pointers, for every one of those pointers I call new. When I'm done, I need to call delete on every one of those pointers. And if I made a dynamic array, I need to call delete on the array. It is a lot of bookkeeping, but it's better than the alternative, which is I am going to make a static array of 10,000 elements. Oh, I ran out of space, right? Or I need to make a dynamic array of 10,000 elements. Oh, I only need 4 slots. Oh, what a bunch of wasted space. Dynamic arrays allow you to adjust to what your needs are at the time. If you had a video game that didn't do a dynamic array, you would be very, very, very grumpy, right? Because it means you wouldn't be allowed to play half the games you would have because your computer wouldn't be big enough. You wouldn't have enough RAM, and the amount of memory that they're requiring would be extraordinary compared to what they actually needed. So, what changed from C++ from before? Well, first of all, we had classes. We didn't have those before. But there's a lot of subtle things that we didn't have before. What you may not have noticed, or because you may have been using it anyways, is we never had the Boolean type before. Bools did not exist in C. If you put a bool in C in 1400, technically you were breaking the rules. You were doing C++. They don't exist in C. You have 0 and not 0. That exists in C, but you never had a Boolean data type, true or false. Now we actually have that data type. It doesn't really make that much of a difference in your lives, but you have it now. You didn't have it before. We have cin and cout, which we didn't have before, and we looked at that. That's with those double arrows versus printf and scanf. We have inline functions, which we didn't even worry about at all. An inline function, how do I describe it without making people cry? Everywhere you have that function call, instead of that function call, it programmatically, without you knowing it, rips out that function call, stuffs the actual code, the body of the function, right in your code, and you don't get to see it at all. It can make your code slightly more efficient. Gamers and people that are doing graphics tend to like using inline functions, but you will not actually have to deal with any of that. We have default arguments which we didn't have before. They're available in C++. So before, if you forgot a parameter, whoops, your thing didn't compile. Now you can indicate, which we are not going to go over in detail, but now you can indicate, hey, by the way, this is what the default value will be here. We're going to look at function overloading. We'll look at that very, very soon. That's when we talk about inheritance and polymorphism. We will hit that. And we have templates for our functions as well. Templating is going to be coming up later on, the last half of the course. All of these are brand new in C++, and they allow you to do some really quirky things you couldn't do before. The Boolean type, again, is the Boolean keyword. If I call bool, it's either true or false, but really it's 0 and not 0. You'll get a 1 or a 0 if you make something a Boolean, but if you give it the number 42, that is true. It's a bit strange in that respect. You're still using I think it's a full 4 bytes. So you use the same size of an integer to store whether something is true or false. Um, so yeah, it doesn't really make, it shouldn't make any difference to you, but this is the kind of thing, like if I have an if statement, that's when Booleans are used. So if this is true, then I do this. That's a Boolean. But it's still under the hood, still, is it true? If it's true, it means it's not zero. If it's false, it means that thing I'm looking at is equal to zero. But then there's the this pointer. The this pointer is weird because and it's also in Java, because it leads to kind of quirky things, but you need them. You need it from time to time. And I remember doing a Java course in my undergraduate years where the professor kept on using this everywhere, never introducing this to us, and we were confused. So here's what the this pointer does. When I call a function like setMonth, if I call this, it means the pointer to myself. The this pointer, I should have a video of myself on this one. It's pointing to me. This me. This pointer. This guy. Who there's that joke, the standard joke, oftentimes in How I Met Your Mother, probably old, it's an old joke right now. You know, who's the guy that corrupts society and has two thumbs? This guy. What or whatever the expression is, right? Who has two who designed crappy buildings and had a meth addiction and two thumbs? This guy. That's from How I Met Your Mother. Um, the this pointer is this guy. The thumb's pointing to yourself. It's me. Me as an object. I want my member variable for month. The reason for this is that you can actually technically, instead of the word int here, sorry, you have int mn, I could have int month and everything would be just fine. It's really strange, but some people swear by this approach. I still actually somewhat swear by this approach. You swear by this approach for one very good reason. If I want the month and I want to make sure I put the variable in the right place, what I really want is to say, no, 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 there's no confusion. Month goes into month, day goes into day, or my ID goes into the my ID field. So this could, if this was, here's the reason for this. If this was month, the name of the variable was month instead of mn. What would happen? I'd have month is equal to month. Wait. I'm going to erase this, by the way, in a second. If I had this be equal to month and I have a member variable named month, which month are we talking about? That's where the this pointer comes in handy. What ends up happening is if I make this month here, I will put then this month here, this month right here, the parameter, it always is given priority. When I talk about the month, I meant this variable here, not the member variable, but this month right here. I don't have a collision. When I say word month, I mean this one right here, not the member variable. So if I want the member variable, I need some way of identifying it's the member variable I'm talking about, not the input parameter. That's where the this pointer comes in. This month means the member variable. Month means the parameter. So this member variable, month, would be over here. I could also say star this, which is dereference the pointer. So I'm now looking at the object itself, not the pointer to the object. Dot month, and I'll get the member variable. Right? All three of these, by the way, do the exact same. If I get rid of this, all three of these do the exact same thing. This is implicitly this month. This is explicitly this month. And this is take the this pointer, dereference it so to get the actual object, get the member variable month for the object, and then set it to mn. This, you can return the current object from a member function by just returning the pointer, the dereference pointer to this. I can return the this pointer so for other people to be able to use my object if I wanted to. It's really useful for naming collisions. This month is equal to month if the month was an input parameter, right? If this is an input parameter like I had up there, the only way to set the member variable would be to call this month is equal to month. Otherwise, month is equal to month, just it doesn't do anything. I have the member variable is equal, the input parameter is equal to the input parameter. So the month variable comes up in weird ways, but you'll see it pop up from time to time in my code and other people's codes, just in case you wondered what it was. It's pointing to itself. We also have constants, which we didn't have, which I think we actually had before, but I like to point them out. The constant keyword, we have some things that we couldn't do before. The constant keyword means that you cannot change it. They're not variables are not modifiable. So const int pi, I can't change that value pi after I've set it. I forget it. I can't modify it afterwards. If I declare a function as a constant function, though, that's where the new thing is. It means it's a read-only function. It means I'm not. If I can have like a get method. I probably should do it with my getter methods. I'm not allowed to change any parameters. I cannot change any member variables with that function. So get ID, I could have const int get ID, and this thing, maybe it says return ID. This means I'm not allowed to modify the ID. I'm not allowed to do anything else. I'm not allowed to change any data with that object. All I can do is return something. It's read only. It just gets me data, and that's it. I'm not allowed to modify member variables. Very useful for protecting yourself from doing something stupid. In terms of object-oriented programming, we already talked about the encapsulation. We also looked at, we're going to look at, so classes provide this sort of template for how objects, like individual objects. Individual objects are the instance of a class, and the class sort of says, what should they look like? What should a Carleton student look like? That doesn't mean that it is a Carleton student. It means anything that is a Carleton student, an object that is a Carleton student, has these characteristics. And then we have constructors and destructors. A constructor builds one of these objects. Destructor cleans it up and gives all the memory back to the system. When we create an object, we make all our member variables as soon as the constructor is called. So all member variables are created first, then the constructor is called, and then we do stuff with in the constructor. The destructor cleans everything up. So it's set up and then tear down. Member variables and objects can be protected, private, or public, protected, or private. And public is so for their structure, they're automatically public. And we'll see why it's important next time around. So a member variable as classes can be overloaded. So given member function, you can have the same function written twice. We've seen that with our constructors. The BIT2400 had two different constructors, different input parameters, and which one gets called depends on how you call the function. I can have two functions with the exact same name, different inputs, and you'll call the right function based off of what the input looks like. We will look at this very, very soon. That's a form, what's called polymorphism, many forms, and we will be seeing this like in the next week or so. Individual members of a class can be static, so they can share across the object. So the static member variables, everybody has access to that same variable. Static functions, all objects have access to the exact same one single instance of that function. Static means it's for the entire class, not for the individual objects. I'm trying to think of a good example of static for like Homo sapiens or something like that, but I can't think of something off the top of my head. So at the end of this, if you can answer these questions, you're doing okay. If you can code something in C++ now, then you're doing much, much better. But the key is to get your hands dirty, get into it, not just reading these slides, not just watching videos. You have to get your hands dirty. You have to actually do these exercises. You cannot cram for this. So what's the difference between a class and a structure? What's the difference between an object and a class? By the way, structures can actually have functions in them as well, but good God, don't do that. Just use a class. Why do we have non-public Member variables and member functions. What's the point of having non-public things? What does a constructor and a destructor do? And how do you break down a big problem into little parts, into these little objects? Well, how do you go about thinking about how you break apart a big problem into small little chunks and how they communicate? If you have a general sense of that, you're doing okay. But I would strongly recommend at this point in time, take a little break, code up something simple. It doesn't even have to do anything intelligent. Just code up something that has an object like like the Rec2400 class. It could be a circle. It could be Pacman in a particular position. You're not drawing anything on the screen. You're just saying Pacman's at this position. It could be student information. It could be calculating your grades. It could be whatever you want. Just get some experience writing a class, especially in a header file and a CPP file, just to make sure you know what you're doing. And then when we come back, we'll be looking at this in a lot more detail. All right. By the way, if you want, we have other examples. So I have a book demo class that's available for you guys if you want to look at them. You'll see constructors, you'll see setter methods, you'll see all sorts of things. The book demo, I might go back to this very, very soon, just to make sure that that we see this and when we think about it. It's a good little practical example for how you go about building things. But I want to look at linked lists, and we'll do that very soon, if not now. Um, if you, by the way, how would you break down? Here's another task you could look at. How would you break down a simple paint program? Right? How would you break down a book class and a library class and the people that use a particular book? How would you take your favorite app and how would you break down that big problem into small little chunks? Okay, and I want to see setter methods, ISBN numbers. That's the number unique identifier for a book. In case you're wondering what an ISBN number is, um, we can talk about. We're not going to even talk about UML diagrams, but if you have a chance or if you want to look into this, you can look into this. This is a whole other world, but this is actually what people really do to write up how are the various classes all interact with each other, talk to each other, what the means of communication between the classes is. It's using what's called a UML diagram. Uh, Unified Markup Language, I think. Anyways, a UML diagram tells you how objects and classes interact with one another, and it's a standardized format that computer scientists, programmers, and software engineers use. But people can get really hardcore about UML diagrams, so I didn't want to freak anybody out about this. What I might do next time around is give a brief look at UML diagrams, and then we're going to refactor this linked list class one more time. Okay? Uh, and we're not going to do the particle system. So actually, I already have a UML diagram thing. Good. Good for me. So do I have an example of a UML diagram? Object diagram. We have class diagrams. Darn it. Oh, there we go. So this would be an object diagram for the various objects that are created from this particular class. We have class diagram. This is the one I sort of I think this should be the one that I sort of grew up with. That we have a customer that's associated with a particular order. So an order has a particular customer. A special order is a kind of order. A normal order is a kind of order. They're subclasses of the parent class. You can see the member variables. You can see other member variables for a particular order. The customers themselves have internal variables associated with them. You can have a many-to-one relationship, so you have a customer with one customer has many orders, but one order has only one customer. And there's a sort of a standardized approach for how we design things, but we're not going to be going over that. Just in case you're wondering, these tools actually exist. That's a whole other class in itself. Okay, with that being said, I'm going to take my leave and we're going to pick up the linked list example one more time when we come back. Thanks.